In this video, we're going to look at logarithmic functions. We're going to look at some of the properties of logarithms. We're going to look at how to go from logarithmic to exponential function, how to solve logarithmic equations, and then how to rewrite logarithmic expressions. So let's get started. Here in example 1, it asks us what log base 25 of 1 is equal to. And this is equal to 0. And remember, the property that we're using is log base b, so any base of 1 is equal to 0. For log base 15 of 15, this is equal to 1, and we're using the property log base b of b is equal to 1. And in this last example, log base 5 of 5 raised to the 3x is equal to 3x. Now we could rewrite this as 3x times log base 5 of 5, and then we can see that log base 5 of 5 is 1 because log base b of b is equal to 1. So that leaves us 3x. And the property that I just used to go from log base 5 of 5 raised to the 3x to 3x log base 5 of 5 is that log m raised to the n is equal to n log m. And we're going to use this. If you multiply by log, you can bring the exponent out front, and that's going to help us in future problems. So those are some of the properties. Now it's important to know all your logarithmic properties. We saw a few of them, and then there's a few more in the textbook, and we may see some more in the following examples. Here they want us to write in exponential form, and we have log base 3 of 81 is equal to 4. And this is a true statement. We just want to rewrite it. And this is going to be an important formula or transition to remember. It's how to go from a log to exponential, because we're going to need it to solve logarithmic equations. So if you have y is equal to log base b of x, and in exponential form, we would write that as b raised to the y is equal to x. So now, in this first example, 3 represents b, so we have 3 raised to the y, which is represented by 4, so 3 raised to the 4th is equal to 81, which is true. And in the other example, 2 represents b, raised to the negative 6 is equal to x, which is 1 over 64. And remember, 2 to the negative 6 could also be written as 1 over 2 to the 6th. Here in the third set of exercises, we want to solve for y. So now we're solving for logarithmic equations. And when we're solving for logarithmic equations, we're going to use what we used in the last examples to turn the logarithmic equations into exponential so it's easier to solve. So here in the first example, we're going to say 1/3, which is b, raised to the y, which we're trying to find, is equal to x, which is 9. And now I'm going to write both of them with the same base. So I'm going to use base 3. 1/3 written with base 3 is 3 raised to the negative 1. And then that would be raised to the y. So negative y, 3 to the negative y is equal to, if we write 9 with a base of 3, that's 3 squared. So we know that negative y is equal to 2 because the bases are the same, the exponents have to be equal to. So y is equal to negative 2. In the next example, we have log base y of 1 over 125 is equal to negative 3. So I'm going to write it in exponential, which is y to the negative 3 is equal to 1 over 125. And now I can rewrite y to the negative third as 1 over y cubed is equal to 1 over 125. And now if the numerators are both 1, then the denominators have to be equal. So y cubed is equal to 125. And we take the cube root of both sides, and we get y is equal to 5. So we can say 5 raised to the negative third power equals 125. And in the last set of examples, we have expressed in terms of log x and y. So we want to use some of our properties to break these apart and write them in simplest form. So when you have multiplication inside your log, you can write that as 2 logs with an addition in between them. So the first step we're going to do is write this as log x to the 4th plus log y cubed. And that is the property log m times n is equal to log m plus log n. And then the next step we're going to bring the exponents down out front. So we have 4 log x plus 3 log y. And here we use log m raised to the n is equal to n log m. In the next example, we have a division inside the log, so the property is log m divided by n is equal to log m minus log n. So this is equal to ln of x squared minus ln, and instead of writing the square root of y, I'm going to write y to the 1/2 power. So the next step is easier. And remember that ln is just log base e, but it's easier to write the natural log. And all the properties that go along with log also go along with ln. And then we're going to use the same property that we used the second step in a. We're going to bring the exponents out front. So we have 2 ln of x minus 1/2 ln of y. And in the last example, it says write as a single log. So in those previous examples, we took one log and broke it apart, and now we want to take and write it as one log. So here we have 2 ln of x plus 5 ln of y minus ln of z. So now we're going to work backwards. The first thing I'm going to do is take all the coefficients out front and put them as exponents. So I'm going to rewrite this as ln of x squared plus ln of y to the 5th minus ln of z. And now whichever ln's are positive are going to end up multiplied together in the numerator, and the negative ln is going to end up in the denominator. So this is equal to ln of x squared y to the 5th divided by z. And that's all for this video on logarithmic functions.